Thank you very much for that lovely introduction. I'm very happy and honored to be here today, and both Chaim and I are. So I just want to show you, there you go, what our presentation is going to be about. We're going to talk a little bit about ourselves, but we want to also talk a little bit about the history of mapping, and specifically about geodata visualization. And then Chaim is going to go over a bit about the role of Geographic Information Systems and show a few examples of this in practice as well. So what we are about, we are a data visualization and GIS company interested in helping organizations and individuals increase the use of sharing of information through a fun and playful and visually engaging way. So I want to start off by defining what a map is. And maps are graphical representations that facilitate a special understanding of things, conditions, processes, or events in the human world. And maps are encoded with a layer of technical, abstract data reflecting either legal, environmental, economical, social, political, whatever you could think of embedded within them. And I also like to describe them as visual instruments that guide the individual through a city or a part of the world that they depict. And I wanted to bring to your attention this really interesting interactive website that I think is you might find really interesting. It's it shows historical milestones in cartography, infographics, and data visualization. The website's called dataviz.ca. And it's spearheaded by York University professor Michael Friendly. And it goes through kind of a whole timeline from pre-1600s to today about key milestones in data visualization and cartography. So I wanted to share a few excellent examples of specifically data maps and data visualizations from that website. And these are also published in a variety of other books. The first one I want to speak about is considered one of the first data maps, and this is from 1686 by Edmund Halley. He's an astronomer, or was an astronomer, and you may know him as well as the person who coined the term, or the name of the Halley's Comet was named after. But he depicted the first known weather map, showing prevailing winds by using these thick line markings on a geographical map of the world. So this is a very simple and clear informative map that describes wind directions in this type of data visualization. Another very interesting key map is this one by Dr. Snow, the dot map of 1854. And this dot map was used to track and visualize the disease data. Now, this is a good example to show and speak about how this data visualization led to the discovery of a source of an infection epidemic. So what Snow did at the time was he actually plotted the number of deaths using dots, and he used crosses or X's to demarcate where the water pumps were in London at the time. And after this data visualization, he began to see patterns, and he noticed some sort of outcome. And what he found that there was a lot of deaths that were occurring near or people who lived and drank from a water pump near Broad Street, so indicating that that water pump may be contaminated. So it actually provided answers, right, through this data visualization. Once that pump was removed, the deaths stopped. So in this case, this type of data visualization actually saved lives. Here's another interesting one I wanted to show. It's Edward Tufte, who I'll speak about as well. He considered this one of the best data visualizations. This is known as one of the first flow maps. This is by Charles Joseph Minard. And it depicts a lot of information on one image. And it speaks about Napoleon's army's march to Moscow in 1812, kind of the disastrous fleet to get there. So you could see the two bands over here depicts quite a lot of information. First of all, the flow and the direction of the army. So the top thick band line represents the direction of the army from the Polish border getting to Moscow. So you can see how thick the army or the troops start off with. And you can see it's starting to thin out as they reach Moscow. Okay, so the beginning of the line indicates that there's over 400,000 armies, and once they reach Moscow, it hits at about 100,000. So you can see a lot, like it basically, it's only a fourth of the beginning of the army that's being tracked at the end. Then at the retreat back, which is the black line, it starts off with 100,000, but when it reaches back to the Polish border, there's only 10,000 troops. But this black line is kind of interesting as well because it's connected also to other types of information. It's connected to lines of location, and it's also connected to temperature. So in the actual lines, it shows that there's an actual thinning of the band when there's a drop in temperature, showing that a lot of people froze during this march back. And you can't really see in this visualization from the slide, but over here, when there's actually rivers and when the armies had to cross certain rivers, there's actually another depletion of the troops. So this was considered one of the best kind of visualizations as described by Tufte because it shows a lot of information into one single graph. Kind of in more modern times, I wanted to show this because we see this a lot in newspapers today. And this is a USA Today color weather map of 1882. And it was done by George Roderick, and he's the one who basically started an era of weather maps or using color of information graphics in newspapers at the time. And it's all over the world now today. So I thought this was a good thing to depict, especially right now how weather is so much an important part of our lives and depicting hot and cold temperatures. I also wanted to bring this to your attention. I don't know how many people are here or in planning or urban design in the audience. But I wanted to speak about the figure ground as another type of mapping system. It's a conventional drawing method for spatial representation and comparison planning and design. And what it does, it just uses two colors, simply black and white, to depict the urban fabric of the city. Typically, black is used to represent built form or the solids, and white is left to represent open spaces or the voids of the city. But in a clear representation, you're able to see the urban fabric of the city right away. And designers and planners also use it in other methods as well. So for example, they could use black to demarcate city blocks, and you're able to see the whole network of the city through the white representation. And one of the kind of earliest recordings of the figure ground was the Gian Battista Noli map of 1748, where it describes kind of the dense pattern of Rome, but the white spaces carve out all the piazzas and the road systems, and also the interiors or the open spaces of the churches at the time. So he included that as part of the representation. Going now into a little bit more creative side from my background in landscape architecture and architecture, I wanted to speak about this early 20th century artist, renderer, and architect named Hugh Ferris. And he's known for his compelling depictions of the 1916 zoning ordinance of New York City. So just a quick background here. In 1916, New York City was enforced to enact on a set of building ordinance or codes, just to tame the increase of skyscrapers at the time. And this was to bring back light and air and health back to the cities of New York. And what happened is once a building reached a certain height, it had to be stepped back. So there was a lot of code, a lot of textual information, and a lot of diagrams to describe what these building ordinance would look like. But it still didn't bring a true representation of what that form would be. And so what Hugh Ferris did was actually bring to the forefront an artistic and very visually compelling approach of the code. And he did this through these large charcoal drawings that could resonate to everyone, not just to city officials, not just to architects, but to the general public and to the common city dweller. And so what these things are, they're works of art, and they're actually three-dimensional guides to the city in which built forms could be built, right? They became the phantom envelope in which buildings could be formed into it. So I personally think that these are the first datascapes or the first three-dimensional maps of New York City's urban form. I also wanted to talk to you about Richard Saul Wurman. You may have heard of him. Richard Saul Wurman is the founder and creator of the TED conferences. He's also coined the term information architect. And this image here in particular comes out from his book of the Urban Atlas, 20 American Cities. And it was done in 1966. And he looked at 20 American cities and showing the density patterns of all of these at a communicative scale. One of the things that I actually wanted to bring to your attention is this idea of the design principle. That he described that one category of data should be represented in one color, okay? And only color intensity should showcase the magnitude or size or change of that thing. And so in this case, he used the color intensification of red to describe an increase of population density. So, you know, the stronger and the darker the red, or the higher the residential population is of that area. And so the wider symbolization of these dots represent a lower population density. This is also from Richard Saul-Wurman himself, another type of visual representation to describe population disbursement across the United States. And he's looking at this through a topographical representation. So you're able to quickly see densities and population areas through this map right away. And so you could see that it's mostly along the coasts and the barren parts of the United States. The middle part is quite flat, right? So it's a quick visual representation to give you an idea of where things are stored, or sorry, where people inhabit. And I guess no data visualization presentation would go complete without talking about Edward Tufte. I'm sure many of you know of Edward Tufte. He's an infographics guru. He's a retired professor of statistics and graphic design from Yale University, and is considered one of the experts in the presentation of information graphics, which includes charts and graphs. One of the things I wanted to highlight about Tufte is one of the terms he coined is chart junk. And chart junk is basically any false or extra or ornamental depictions that are useless in a graph. And that could be things like hatching, dark grid lines, or wave patterns or motifs that do not need to be in the actual representation. Another key figure that I want to speak to you about, me being as a landscape architect, is James Corner. You may have heard of him. He's the designer of the High Line in New York City. And he really professes this idea of creative mapping. He believes that mapping is part of a creative process. And he also believes that maps can be works of art that can reveal hidden information of the site. And in 1996, he and Alex McLean, who's an aerial photographer and actually an architect as well, took these lovely, beautiful pictures of aerial photographs across the United States. So in just having the aerial photographs, James Corner took another approach. He created these supplementary, what he called map drawings, which highlighted things that are not normally shown in the aerial photographs. And it could be things like a hidden riverbed, or it could be things like the grid lines of an agricultural field. He just brought that to the forefront through this type of visualization. Another architect that I want to speak to you about is MVRDV. They're a really well-known Dutch architecture firm. And in 1999, they did this research project called MetaCity Data Town. And they came up basically with the term datascapes. And they were examining quantities, specifically data pertaining to cities, and how could they be analyzed, and how can you analyze its components and manipulate them. So they wanted to describe a city or create a city that was only based on pure data. And how could that city be explored based just on information? And they specifically looked at data sectors, 6 of them, living, agriculture, CO2 or forest sectors, water and waste, and energy sectors, and looked at these kind of hypothetical or what-if depictions of the city if it was just based on information. So from maps to datascapes, datascapes are essentially multi-dimensional representations of cities or landscapes based on the data associated with the site. They are the visuals of the intangibles that are often invisible forces that shape our city. And as I described before, I think Ferris was one of the first people that turned statistics into some sort of architectural language. So after looking at all these kind of figures and key people that have shaped the role of creative mapping, I put together this book called The Exposed City, and I was really interested in the way that we redesign the city and create new form through information that is typically invisible to the human eye. Things like crime rates, transportation patterns, cell phone usage, air qualities, and what kind of shape would this take? What kind of shape would it take place? Or how could it be mapped? And how do you begin to design it and represent it? And then how do you make sense of all this data? So at the time, this was about 10 years ago, using kind of off-the-shelf softwares. I started off with a simple base map. Okay, we all started off with a simple base map in urban design and in architecture and in landscape architecture. In this case, instead of looking at a small site, it was looking more at a city scale. So I took the kind of census district map of the city of Toronto, which was given to me. And then on the side here, you see a menu of data, right, with the ID number of each of these districts. And each one of these data sets beside them is the number of people living or inhabiting in these districts. So what I was looking at is how can I create a new landscape of the city just based on these two components, the site and the actual data on hand as a menu. So I took what I would consider this base map and turned it into what I would call like an edible mesh, right? This became a flexible surface, a flexible plane, in which data was then interpolated into it. And then I used simple principles in terms of pushing and pulling based on the information. So the higher the number, the greater the pull. And this was the kind of landscape that was generated after several iterations. Using that data and using that base map, this is the kind of pattern that residuated or came about in that space. So this became a map as a landscape of information depicting densityscapes of the city of Toronto at the time. And so through this quick visualization, we're able to reveal certain patterns. We're able to see through the high peaks where there's a higher placement of population, and we're able to be engaged with this type of data in a much like at a higher level. Taking it another step further, I was looking at the way we could present data in another way as a sculptural form, seeing that whole process, making it seductive artifacts, allowing the audience to be much more engaged with the information. Also looked at data as spaces. This is another way of representing it. In this particular space, I had data for the Great Lakes region and looking at the toxicity levels around the Great Lakes region. And so I created these things what I call bubble spaces, right, done in red rendering. And the larger the bubble, the greater or the more alarming is the toxicity level. But throughout this whole process, these are the kind of conclusions or the kind of bases that I always try to bring together in creating a data visualization specifically pertaining to mapping. And it's this balance between the creative and the design and the logic and the information. You want to make the information somewhat seductive, right? You want to attract the audience to it. You want it to tell a story, but at the same time, you want it to be knowledgeable, and you want it to be true and informative. And you want it to make it dramatic in some cases, right? You want to draw people's attention to certain areas of the site where it needs to be. You want it to be engaging and artistic. So every time I look at a data set, I try to look at these types of principles and bring them into the creation of the actual visual. So that's a little bit about the history of it. Right now, I'm going to pass it over to Chaim, my colleague, who's going to be speaking specifically about GIS, or Geographic Information Systems. And I'm going to be showing you then a few sample data visualizations in practice from different various data sets, some that we have collected and some from open data platforms. Okay? And we'll, I guess, take questions at the end.
Okay, So that was a fair bit of information around the evolution of maps, and there was a lot of theory in terms of the use and the design of maps and how it should be used to present and visualize information. So one of the best ways to actually leverage all these concepts is through modern forms of geographic information systems, or commonly known as GIS. And essentially what this is a combination of hardware and software, which is used to take data and basically turn it into a map. And so the advantage of maps as a data visualization tool is that it far exceeds the benefits in terms of presenting information than what you could normally get out of a typical table. And it really does it by giving information context in the form of location, which I can't really see from just a flat table. So the way that typical GIS platforms work is it allows the end user to take a base layer of a map and overlay different types of information on it. And by layering this information, the user can actually compare and contrast the information from in a visual means, as opposed to having to look through tables and tables of information. So I'm going to take the concepts that everybody heard about, and I'm going to talk about those in relation to GIS and how that combination of the two can actually be used to make sense of information, actually make it a lot more interesting and more usable for everybody. So just starting off with one example here. So this is a typical data set that any organization may have. This is the distribution of an organization's product across different locations. You can see that rather than looking at it through a flat table, I can actually see it visually on a map, and it quickly tells you where the product is being sold. And the size of the markers is actually telling you the amount of the product that's being sold. And so what we can do from here is take it a step further and visually analyze this information. So if I was this organization and I wanted to know where I may want to put my warehouses to optimally sell to these retail locations, I can quickly do that on a map. And if I make the assumption that it's most efficient to travel 50 kilometers from each warehouse, then I can quickly see where they should be, where each of the warehouses would actually be located. So another example is taking different forms of primary data and using data visualization to actually make sense of it. This is actually CO2 readings taken from any type of a handheld sensor or mobile phone. It's actually thousands of points that's been collected over an hour, but it would take a long time to actually sift through all those, as opposed to making an image or a map from it. You can quickly see by using different levels of shading, it's actually really easy to see where the higher levels of CO2 are along this path. So just focusing on open data now. There's a number of different examples, and we've taken a few from different portals and countries and so on. Here's one example of planning for natural disasters, and what you can see here from the New York Open Data portal here is right now is the number of damaged trees prior to Hurricane Sandy, and after the storm moved through, then you can see what it looks like. But you can see how easy it is to actually see and analyze this information visually, as opposed to having to look at it through a flat file. This is just another example from New York. This looks at electricity consumption. You can see that the use of height is actually showing which districts have the highest levels of electricity. So just moving overseas to London, UK, these are their planning districts. And this is just some demographic data that was on the open government portal here. And what you can see here is that the number of cars per household actually increases as you move further away from central London. And out of the same data source, this is looking at population, specifically 16 to 24-year-olds. You can see that they're more concentrated within central London as opposed to the outskirts. So for some reason, it's the opposite of where where the cars are actually being used. Looking at a larger scale within the US, this is showing the population by district. You can see again, just by simply using height and shade, you can quickly see where are the highest levels of population. And similar data, except now we're looking at the levels of poverty. And you can see that the darker areas are showing where are some of the higher levels within the United States. So just moving a little bit more local, so now within Canada, and I'm going to go through a number of different data sets, both from city all the way up to province and country. It's first starting from the city, at the city level, we can see here, these are the number of males by planning area, and I can do the same thing for the number of females. And the two look fairly similar. You can see by the darker shaded areas, populations are high for both. But the advantage of data visualization is I can actually overlay the two. And what happens here is that you can see that for most planning areas, there's a higher level of females than males, and that's actually true for almost all the areas in Toronto, except just down in the south there and on the west corner of the city. And then taking data from the same area there, you can see this is, if we're looking at data for the purpose of healthcare, we can see that the screening rates for breast cancer are actually higher within the central area of the city. And then just one more example from the city of Toronto. This is the number of accidents. And you can see for some reason, we have the worst drivers are on the two corners of the city. Okay. This is an example of data visualization. It's actually following a path of the LRT in the city of Edmonton, and the height is actually representing the ridership levels at each of the stations. This is a really easy way to actually see something like where are areas where what are the areas where that's seeing the most traffic and maybe causing some of the bottlenecks within the system. Just on the topic of traffic, this is the number of people that are using the public transportation system just in southern Ontario. Obviously, you can see that some of the highest levels are just within the center part there. And so what we can do is take this a step further. If any planners in the audience, this is the same app imported into 3D modeling software, which can actually drive a lot of the data-driven design concepts that we keep hearing about today. And taking it one step further, we can actually take the same app and create a physical print of the information as well. Just taking data to a whole nother level where there's an actual physical object, which is represented by information. It's just moving over to the West Coast. This is from the city of Vancouver. Each of the green squares there is representing a park within the city. This is another example of analysis. So if I make the assumption that people are willing to walk 500 meters to a park, if I visually show that on a map, I can see that there are some gaps within the city that aren't meeting that criteria. This is similar data, except it's looking at gardens. But what this is showing is an example of using textures as a way to actually help explain what is the type of information that we're actually looking at. And so just moving to a broader area, area here. This is within the province of Ontario. It's actually taken off the federal government's portal. This is actually showing the carbon gas emissions from various facilities. And you can see through visualization how easy it is to actually see which facilities are the highest polluters. And then just lastly, so there's a couple data sets here that we had pulled off. This is at the national level, just looking at different types of expenditure by the government of Canada. This here is looking at expenditure on public libraries by province, and then on museums, and the use of shading here is putting provinces into common groups, so you can see which province is actually spending the most in these spaces. Just lastly, to close, what I want to show you is just on our website, there's actually a gallery that's open to anybody, and it's actually being built by the community. And this is where people are actually uploading the information that they have created in the form of maps. It's a really good source for inspiration and to actually learn more about how some of these data sets are actually used in practice today. And this, as mentioned, this grows every day as more people are uploading their information, and a lot of the sources are actually from different types of open data portals. So that's it for the presentation.
Thanks so much, Naeem. Really appreciate it. And come on up.
Okay.
Thanks so much for your presentation. What I'd like to do now is just ask if there's any questions from the audience. No, this is a very interesting area. Questions? Yes.
I'm curious about the map that you got from Open Data Canada and your experience in accessing data from them, and whether you've experienced any restrictions on access to data from Open Data Canada. We're quite aware of constraints on scientists providing information and opinions. And with respect to today's discussion, I'm looking for experience in whether there's any restrictions or constraints in accessing information from the Canadian government.
Sure. So I had specifically went on that site for the purpose of this presentation because I wanted to see what was available. And to be honest, it was one of the largest data stores that I've actually seen, as some of the other ones that I've actually used. Like I think when we were going through it, and we specifically searched for tags on geodata, and I think we were looking upwards at 20 or 30,000 data sets. So in terms of access, it was very accessible, and there was a lot more information there than I've seen on other portals.
I really liked your presentation.
Thank you.
I've been in engineering. I've never really visualized, or this is new information for me. And I was wondering, after analyzing, did you or did anyone else create something functional that would be useful from the data?
Yeah, so I guess it depends on the industry. Specifically, if we're looking at the first example that I showed that was related to retail and supply chain, that data set was actually used to decide on where the optimal location of a warehouse could be to make sure that it's as efficient as possible to actually get to those locations, right? So what this does, like any other type of data analysis, it kind of gives a vehicle for that first level of analysis to actually help a company make a decision. That's one example. You know, within the healthcare industry, if you're looking at understanding where patients are coming from relative to a hospital, it actually helps with being able to plan into the future in terms of making sure that the hospital has the capacity to take on patients as they move into the future.
Hi, thanks. I have a question about the programs that you're using. What are they, and are they available to anyone, I guess, or are they paid programs, or I don't know, what are the options?
Sure. So the program is actually it's our application. It's actually available right from our website, just DataAppeal.com. It's open to anybody. It's actually free to use as a start forever. It's not a trial. And if you go on the website, you register, and you can go ahead and use it. It's the actual application has been designed. So we mentioned at the start my background as a data analyst. This application has been designed in a way where you don't have to be an analyst to use it. So all the concepts are embedded into the application, but you don't have to have that type of training in GIS and things like that to be able to actually leverage the application. So it's open to anybody, and it's really simple to use.
My name is Craig. Question about popular dimensions. So one dimension we know is geography. The other one is the amount that varies. What are the next few dimensions that are most popular in terms of depicting for decision making?
Yeah, so I would say, do you want to do it?
Yeah, so one of the things we haven't shown here, but even through our application or any other sorts is the idea of the time dimension. So in our specific data sets, if you upload information that has a change in time and a growth pattern, these images that we showed you, for example, bubbles or the kind of shape files, they would actually then change or fluctuate depending on the data that gets embedded with them. So I think the time dimension is really important.
So if you think about it,
Yeah.
where typically in a flat map you have 2 dimensions, what we've done here through height is added a third. And through a time dimension, which is automatic from this application specifically, and so we actually added a 4th dimension for analyzing data. So as opposed to something that's typically done in 2, you can actually do in 4 dimensions.
I'm actually just curious about visualization and how it maybe affects social movement. So if people now have access to this information, are they using it to kind of create change? Or I'm just wondering if there's any like cool effects that come or outcomes that come from this.
So in terms of social change, I could speak from some primary data collection that we've been working on. It was about a year ago, went to the University of Florida, and a whole bunch of students were looking at a street corridor in Miami Beach and looking at traffic counts of where people were grouping together. And so they, each student had their own location where they were tabulating numbers. And at the end, they got together and put this in a data file and then visualized this information in a visualization and then noticed areas that had the most popular hotspots of the city. So that informed them in ways in terms of the design process of where perhaps to bring in more venues, nightclubs and bars, just based on that data visualization.
What are elements of bad map design?
I think Nadia can talk about this forever.
Well, me personally as a designer, I don't like maps that look scientific, right? Scientific maps. And those are good maps too, just to get hardcore information. But one of the things that I like to say is I like to sex up the data, make it, pretty. So at first you're attracted to it, but in some of the maps that even Chaim was showing, if you go into the actual application, you could actually click on those markers and will pop up a text box that will give you more information, right? So it's this kind of coat or this kind of fashion that first attracts you into it, and then you could go dig deeper and find out the actual raw numbers. But I think it's really important to bring that visual effect right away to the person, and then they could dig deeper into the actual information.
Hi, my name is Laura from Communitech. Just a quick question on the interaction of data. So traditionally, data was held by people and they analyzed it and then presented it the way that they wanted to. Where do you see the increase where there's an interaction with that data and there's feedback? How do you think that will affect the visualization of data in the future, if that's evolutionary or revolutionary?
So I think that what data visualization does is it helps to create that sharing of information, which in the past you may have not been able to actually get, where there's that expert that was creating the information and then sharing it with others that were consuming it. I think using tools such as this or others, what you get is more than one person that's actually creating the information and sharing it. So it becomes a two-way street, as opposed to kind of where you have one person that's giving out the information to others. Because all of a sudden, analyzing data becomes much simpler, as opposed to somebody having to need all the expertise to actually do all that.
I think we have time for one last question. You see how explicit your lecture was.
A lot of questions. That was great.
You've answered all the
Okay,
questions.
great.
Thank you so very
great.
much,
Thank
both
you.
of you, for
Thank
coming
you.
this afternoon.
Thank you.
Thank you. Thanks so much.